About chemical reactions, and you guys have got the notes. And on top of that, you were kind enough to do your what do you know for me. And we got some interesting responses to your what do you know. So I'd like to share a few of them with you. And of course, this is highlights only, and no names are attached to these responses. Type everything you know about chemical reactions. It's when you put two chemicals together and something happens. Okay? When two chemicals are combined and they either make a compound or explode, chemical reactions can make explosions.
That's true.
Chemical reactions happen when you mix chemicals. Chemical reactions occur when you mix more than one chemical. It's when things react chemically. Chemical reactions happen when chemicals react with one another. Okay. Well, they are caused when chemicals combine. Okay, fair enough. And there are different types of chemical reactions, and my personal favorite, I do not know much about this subject at all. We're gonna start someplace. So, I have got a pretty nice little rogues gallery of chemicals up here, and we're going to talk about some of them. I have here, you need a signature, don't you?
Unfortunately.
Can you come back in a minute?
I can come back maybe at school.
Perfect. So I've got this nice colorless, odorless chemical here. This is 11% hydrogen by mass and 88% oxygen by mass, roughly. It actually is water.
Oh, okay.
Yeah. Colorless, odorless, 88 and 11, oxygen and water. Yes, it is. It is our old friend H2O. Is it a chemical? Yeah. It's got a definite chemical. It's got a definite composition. Any sample from around the world of pure water is going to be the same. It's going to have the same characteristics. Boils at 100, freezes at 0. Blah 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 blah. Fantastic. It's a chemical. What's this?
Aluminum foil.
Aluminum foil. Aluminium, as the Brits say. Is it a chemical?
No.
Yes, it is. It's pure elements, but it's chemical for sure. It's got a definite chemical composition, definite melting point, definite point below which it's a solid, definite characteristics in terms of conducting heat and electricity. It happens to be a metal, so it is able to be pounded or pulled into thin sheets, which we call what? Malleability. Yeah, it's malleable. Yes, the sheets can be called foils when they're this thin. So, I'm going to take this chemical. As we said, chemical reactions happen when chemicals are mixed. Put it in the beaker. Oh, can you guys please put on your safety glasses in the front here? Okay. We're waiting anxiously. Yeah, okay. So, let's dispense with our first notion. Do chemical reactions always happen when two chemicals are mixed? No. Not all chemicals react. So, that's a good point to start from. So, our aluminum is not reacting with our water. Okay, so much for that one. Now, let's look at... Yeah, let me dry this out carefully. I've got another colorless chemical here. It's not odorless. It's got some pretty good fumes. Make sure this is nice and dry. All right. So, colorless. This is 2 molar hydrochloric acid. It's slightly more concentrated than the hydrochloric acid that you were working with the other day. And I'm going to take another piece of my aluminum, crumple it up nicely so it sinks. I'm going to drop it in there. No, it didn't sink, I know. Darn it. No, it's not about the sinking. I'm going to have to get out the 6 molar hydrochloric. Piece of copper. Come on. Oh, booger. Well, once again, we're disproving the notion that if it's physics, it doesn't work. Here it's chemistry if it doesn't work. Apparently, even 2 molar is too dilute. I will get the 6 molar out in just a little bit. Okay, so we'll set that one aside for right at the moment. Sigh.
Didn't it just work last week?
We'll talk about that a little bit. So, I've got here another little beaker. I have some household chemicals. Actually, let's see if we can get this one to run. This one's a good one. So I've got sucrose. You can go anywhere and buy this. Sucrose, table sugar. It's a reducible sugar. It's a combination of fructose and glucose. We can break it down into its component sugars. David knows one of the things that may happen if I can get this to work. Basically, I think you can use him as a weather gauge in here. And if David's excited, something good could happen. So first of all, we're going to take our sucrose here. We'll take the smaller one. And we've got our colorless, odorless liquid, our H2O. We're going to add some water to our sugar. Anything exciting happening there? Front row? No. Well. Okay, so now we've got our sugar and we've got our 2 molar hydrochloric acid. This is a not as dramatic as sulfuric. Okay, are we going to get a response? Come on, I'm going to have to get out the 6 molar. I cannot believe it.
What's supposed to happen?
I'll get out the 6 molar and show you in a little bit. I'm not going to ruin it for you. Okay, well, that's anticlimactic. Okay, let's do one more. Here's one I know I can get a rise out of. So we've got our friend sodium bicarbonate. What would be the formula for sodium bicarbonate? Na.
C2. Carbonate.
Check your ion Bible, please. Ion Bible. You're getting closer.
CO4.
No, getting colder.
Did you say
Sodium bicarbonate.
So would it be CO3 with the brackets?
No. Ion Bibles. What? Bingo. Give a prize to the lady in the front row. NaHCO3. The bicarbonate ion is the HCO3. There we go. Okay, so we've got our sodium bicarbonate. We'll put in a generous helping here. We've got our 2 molar hydrochloric acid.
Is that just vinegar?
No, it's hydrochloric acid. Same principle, though. Same principle. Make sure we've got all our hydrochloric acid stirred here. Whew. Okay, so jot down anything you observed. At least it's more exciting than past ones. Yeah, totally neutralized. Fantastic. Love that sound. Okay. Tell me one thing that you observed. Somebody who is wearing, I'm getting really creative with the clothing lottery here. Somebody who's not wearing jeans.
Bubbles. Fizzy bubbles.
Fizzy bubbles, okay. Anything else?
No.
Oh, you got an odor. Okay, good. Are you?
Did you really smell it?
You're in sweats too. Okay, good.
There was like stuff coming out. Like,
Okay, we had pretty robust bubbling. We had, hence the fizzy part. Okay, good. We'll set that aside for the moment. Let's see. So if we take copper nitrate, copper 2 nitrate here. It's our beautiful blue stuff from yesterday. And we put some copper 2 nitrate into a beaker. And it's just the prettiest color. Now, and this gets to another important point. I said yesterday I could paint my whole house copper 2 nitrate blue. I think it's so pretty. Chemicals all have a distinct color, don't they? This is my sodium hydroxide solution. Clear. Water, clear. Hydrochloric acid, clear. Acetic acid, clear. Copper 2 nitrate, not so much. So, chemicals have a distinct and signature color. So now we're going to go ahead and mix in some sodium hydroxide, or, yeah, it is sodium hydroxide. And what do you see?
Turn to a lighter blue.
Okay, jot down everything you observed there. I'll hold it sideways for you. Oh, you need to get glasses.
I don't know what I asked Jane. She was like, your teacher's probably going to write you a letter.
Okay, everything you observe. Somebody who is wearing something above the waist that has buttons. Did I get anybody? Okay, somebody who is wearing something above the waist that has a zipper.
It changed color.
Okay, it changed color. We went from that deep, deep, beautiful sort of cobalt blue to this much paler blue. Somebody else with a zipper.
Got chunky.
Got chunky. We formed a what?
Solid.
A solid, and when we form a solid out of solution, we call that a precipitate. Because remember, if you're not part of the solution, you are the precipitate. Okay, good. Good observations. Good observations. Now, if we add a little bit of hydrochloric to that, what happens? What just happened?
You're not really
An
Is
unchunkified
that what
magnet.
happened?
It unchunkified. I like that. I'm going to use that.
New word.
It unchunkified. It cleared right up. That's kind of weird. So, we had a precipitate disappear spontaneously. And the color is definitely not the same as it was. These things are distinctly different colors. Okay. Good. So we've got some observations to start with. I'm going to pause the video before we start on the notes.